Alright, welcome to my YouTube channel. On the board we have three resistors that are connected in series. The current is not given and the total voltage is given. So we have the total voltage as 80 volts. We have the resistor 1 as 4 ohm, the resistor 2 as 6 ohm, and the resistor 3 as 10 ohms. And we are asked to find the total current, the power in each resistor, and the overall total power. So first of all, we know in series circuit, when resistors are given to you in series, you only add them. So you say total resistance equal to R1 plus R2 plus R3. So total resistance is equal to 4 plus 6 plus 10. Total resistance is equal to 20 ohms. So we are told to find number one, total current. So we say number one, our total current is equal to, we know current in Ohm's law is voltage over R. So total current, our voltage is given as 80 volts, 80. And our total current that we've just calculated by adding this three, which is 20 ohms, will come here. So total current is equal to 20. When we divide 80 with 20, we have our answer as 4. So the current is 4 amps. 4 amps. So right now we are asked again in number 2 to find the power in each resistor. So here we say number 2, power in R1 in resistor 1 is equal to, we know the formula for finding power. We have 3. So let me show you the 3. We have power is equal to IV. We also have power is equal to I square times R. And we also have power is equal to VR, V square over R. But for this case, when you check here, the formula we have to use here is we have the current and we have the resistance. So we have to use this. Power is equal to I square times R. So we say number 2, power 1. Power 1, we name this one as power 1, name this one as power 2, and name these 3 as power 3. So power 1, we say is equal to I square times the R1. So power 1 is equal to I square, our total current is 4. So 4 squared times R1 is 4. So power 1 is equal to, let's see what we have. 4 squared times 4. We have our answer at 64 watt. So this becomes our power 1. So power 2 is equal to I square times R2. The reason why we are using the same current is because it's in series. So the same amount of current flows in each of these resistors. So we say power 2 is equal to I is 4 squared times R2 is 6. So power 2 is equal to 4 squared times 6. 4 squared times 6 will give us 96 watt. 96 watt. And then power 3, we have current squared times R3. So power 3 is equal to, our I is 4 squared by R3, which is 10. So power 3 will be, so 4 squared times 10 will give us 160 watt. Alright, so this is the power that dissipates in each of these resistors. You can also use the voltage drop to check. So let's use the voltage drop and see to check whether we'll get the same answer. So voltage drop in R1 is equal to what? Total current times, this time you don't square the current, so it's total current times R1. So voltage drop in R1 is equal to 4 times R1 is 4. So voltage drop in R1 is equal to what? 16 volts. So how you can find power here is that we have the voltage drop as 16. We have the resistance also as 4. So you can see power is equal to, we have the voltage drop as 16 volts. So now it will become V squared over R, which our V is 80 squared over R. Where's our R? Which is 4. So power, let's see whether our power 1 will be correct. So let's see, 80 squared is 80 squared divided by 4. No, it has to be 16 is voltage square rather, so 16 squared. So 16 squared divided by 4. Yes, we have 64 watts. You see that power 1, when we use the voltage drop, is similar to here. It's similar to the one we use, I squared times R1. So let's check power 2 with the voltage drop. So voltage drop in R2 is total current times R2. So voltage drop in R2 is equal to, total current is 4 times 6. R2 is 6. So voltage drop in R2 is equal to 6 times 4 is 24 volts. So let's see our power 2. Power 2 is equal to voltage square over R2. So voltage square, which is the 24 squared, over R2, which is 6. Let's see whether we'll have 96. So our power 2 becomes what? 24 squared divided by 6. Yes, we have 96 watts. So let's see our power 3. Power 3, which is equal to, okay, let's use the voltage drop, voltage in R3, which is equal to total current times R3. So voltage drop in R3 is equal to 4 times R3, which is 10. So voltage drop in R3 is equal to 40 volts. So power 3 is equal to what? Voltage square over R3, which is 40 squared over R3 is 10. So our power 3 is equal to 40 squared divided by 10. Yes, we have 160 watts. So as we can see, when we use the I squared times R, the total current squared times each of the R of the resistors, we have this. And we use the voltage drop also, we have the same. So the 64 as power 1, 64 watts, power 2 is 96 watts, and power 3. And we are asked to find the overall total power. So the only thing you do is, so sorry, let me put my number 3 here. So what you only do is that you say total power is equal to power 1 plus power 2 plus power 3. So our total power is what? 64 plus 96 plus 160. And then when we add it, so let's add it, 64 64 plus 96 plus 160. We have 320 watts. So this becomes our number 3. Right. So this is the answer for a case like this. You can either use this as I squared times R when it's given in series, when your question is asked in series form, and you can also use the voltage drop by using the total current. That one, you don't square the current, you go by the total current by each of the resistors. That becomes your voltage drop. Then you divide you square the voltage over each of the resistors, and you have the watt, which is the same as when we use the I square times each of the resistors. So for now, this is the answer. Meet me on YouTube. Go on YouTube, write David Tete into brackets, calculation and practice, and you see more of my calculation. Subscribe, comment, and share my videos. Bye for now.